You are listening to Within Tolerance, a podcast for machinists by machinists. I'm your host, Dylan Jackson of Proteum Machining, and this week I am very happy to welcome Denis Basaric. How's it going, Denis?
Good. How are you doing, Dylan?
I'm doing great. I'm really happy to have you on the show. I've seen your stuff on Instagram forever. Absolutely gorgeous products. Please tell us, who you are and what you do.
So my name is Denis Basaric. I am the owner of KafaTek, and we make high precision espresso grinders,
which we can see for those watching the video behind you.
Yes.
Absolutely gorgeous.
Thank you.
Well, then let's get into your backstory. I mean, I know from the Patreon, James Mayette was asking, what gave you the idea to create an espresso grinder? But I want to step it even further back than that. What even made you want to start in manufacturing?
Like many people on the podcast, I started at very early age to build things. I always like to make things. And I started with the electronics first, like building radio receivers and stuff like that. And that was at a very early age, like maybe when I was 10. And I had a good mentor, and, he was teaching me every week how to build stuff, how stuff works. And, at that time I saw the first computer, and I was fascinated by that. That was huge. But then wanted to learn more about it. But I'm from Sarajevo, Bosnia. So at that time we didn't have, the computers were extremely expensive. So you can only find one. I found a computer club in the city where the, geeks would get together. And, we would spend nights working on the computers, just programming. And, the interesting thing is back then, the computers we had, they're very old. So you couldn't even save the programs.
Oh, wow.
So you would write them down in a notebook. And then the next day you came, the first thing you do, you type in the stuff from yesterday, and then you continue working. And, those first computers had only two programming languages. You can program in BASIC, and that's what I learned first, or you can program in Pascal. And not Pascal, the assembler, sorry. And those are the two choices you have. So I first learned BASIC, and essentially how you learn, you ask people, what does this do? You had a couple of simple programs that you type in, and then you see what they do and you try to figure it out. So basically everything, from very early age, it was how to learn things by yourself. You couldn't survive in that club if you weren't able to figure things out yourself. That was the first thing. And I think that carries on to this day because, I think that built the confidence at early age that I can figure things out.
Totally. Yeah, I think that's probably a sentiment that many of the listeners share as well. I think that's probably a pretty common through line in a lot of machinists, especially people who are listening to podcasts and, on social media and all that, and learning constantly is how, we're all very much self-starters. It sounds like you took that to the nth degree. I can't imagine learning to program at a time where we didn't have, nice fancy tools that start telling you where your errors are. You're just well, it didn't work.
Yeah.
Didn't work.
Well, and that goes to the very extreme. I remember I learned Pascal, I learned BASIC, I learned C and C++, and I wanted to get into the assembler. That's the lowest to the metal code. And I wanted to learn that. And I was asking, a friend of mine from that club, and, he's a genius. That's probably the smartest person I ever worked with. Extremely intelligent. And I was asking him okay, how do I learn the assembly? And he's you learn it like I did. I was how? And he brings me a printed out ROM code from the ZX Spectrum. I think it was first 16 kilobytes of the assembly code. And he says, start reading from the line 0 and go down. And by the time you are finished, you should know what's going on in there.
Oh my goodness.
And that's how he learned. And that's how I learned, And I was asking him, okay, what does this do? And, so that's kind of, I think that's what gave me the confidence. Yes, I can dive into something and I can figure it out. And that's like my preferred mode of learning, either find a book or just dive in and then figure it out. I think, that for me is the best. And then another thing that I really do like is just getting deep. Go to the bare bones and learn how things work underneath.
Mm-hmm.
So that was kind of like, the basis, I think, for, getting into the machining.
Totally.
But how like the whole thing with the coffee grinder started, like that goes all back, I give credit to my wife. So like years ago, she said, well, we are spending way too much money buying coffee outside, we should be able to make that at home. I was like, sure, it's the espresso and the milk, we should be able to make that at home. And then I went into the research mode, trying to find out, how to do it. And at that time, I remember reading, you can either get the espresso machine and the grinder separately. And that's like the best way to do it because then you have a control. But you can also get, like, if you don't want too much work, you get the super automatic machine. So that machine integrates the grinder and the espresso machine. And all you do is just pour the beans and push a button. And I was like, okay, I'll get that. And I bought that and we used it for, a couple of years. And then one day, I don't know why, I felt the coffee is not tasting that good. And I made straight up espresso. I was like, let me try how that really tastes. And I tried the espresso and it was disgusting. I was like, I can't drink this. And then I was like, okay, time to step this up. And, and then I started, the research again, and I got, okay, this time I'm going to buy the espresso machine separately and the coffee grinder separately. And that worked great. Like, the coffee was good. I was learning how to make it, learning what I like, what I don't like, and I bought like the coffee grinder at that time. That was like years ago, maybe even 20 years ago. Like all the coffee grinders were pretty much made for the coffee shops.
Right.
So
yeah, because that it wasn't that big at that point, right? We're talking early 2000s then at that point?
Yeah.
So, yeah, because the coffee scene's exploded in the last decade. But I mean, I think that even the V60 was maybe not even out then.
Yeah, I don't think so. I don't remember, but
yeah,
we always liked the espresso. And I bought those grinders, and the best grinders were commercial grinders. And what that means is you have a big hopper on top and the coffee goes inside, and then you just grind coffee, as you need it. The problem with that, if you use it at home, you waste a lot of coffee because you have a long grind path where the ground coffee accumulates. And then even if you change a grind setting, you have to purge some coffee. You have to purge out whatever is in a buffer, if you will, to get to the new coffee. And essentially, if you get a new coffee bag and you are starting from scratch to dial it in, like you might use the whole bag of coffee.
Oh, wow.
Yeah, just to make a couple of shots. And I was like, this doesn't make any sense. And like, I think there was a one single dosing grinder back then. And that was a VersaLab. So the guy that designed it, I think he passed away a couple of years ago. And I remember I bought that grinder, and basically the single dosing grinder, that means you measure the beans, 18 grams, whatever, and you dump them into the grinder that grinds, and that's what you get out. So there is pretty much no waste. And I was like, this is great. I used it for a couple of months, but then the kind of quality degraded. And I was like, I don't know why this is. I don't like it. And, maybe I could design my own grinder. How hard could that be? And
famous last words.
Yep. So I was like, it can't be that hard.
At this point, what were you doing professionally?
I'm a software guy.
Okay.
So I've been writing software, as I said, since I was 12.
Okay.
So I love doing that. I was doing that professionally. And I was like, okay, maybe I'll design my own. How hard could it be? And I don't remember the 3D software I used. I think, was it Cubify 3D, something like that. They changed the names like a bunch of times.
Yeah.
And I used that. I designed the first, and I had no clue about machining whatsoever. I knew nothing. I thought you draw it in a CAD and that's what it comes out. Like you say, I want it 30 by 30 millimeters. That's exactly what you get. Like there is no tolerance. There is no variation. It just comes out. It's a CNC. It's a computer doing it.
Oh, yeah. I think, unfortunately, many of the listeners, and me included, have had many a customer who think that exact same way as well.
Yep. So, and I designed everything. And the first thing I did, which was kind of interesting, I was like, okay, I'm going to make it locally, find a machine shop to do it for me. But before I did that, I 3D printed everything. And that's immediately when I realized, oh, the stuff doesn't fit. Okay, why doesn't it fit? Well, there is such thing as a tolerance. If something needs to be smaller, something needs to be bigger if you want things to fit together. And, okay, then I changed the design a little bit and I found a local shop here, Birdwell Machine. So since then, the owners, John and Mike, are kind of friends. And, I gave them that. They made the parts. I put it together. We made some little changes and the grinder worked. And I was like, okay, this is great. And I used it for a year. And at that point, I figured out like all the mistakes I made, the stuff that I didn't like. And I was like, okay, let me make another one. And then I, did a design revision. They remake me the parts. I put it together, works great. I was like, fantastic. And I kept using that. And one of my coffee friends, he's like, you love that grinder so much. Can you make me one? And, at that time, like, as you know now, and I know now, like, you can't order one piece from the shop. Like, whether you order 1 or 10, it doesn't really make that big of a difference in price. Right. It's all in a setup and programming. So I always ordered like 10 of each. So I had like 9 extra parts. So I made him one and he loved it and he kept using it. And I think he posted on the internet about it on the coffee forums. And, slowly I get requests from people, can you make me one? And, I made those like first 8 or 9 and I sold them. And I never intended to make this. Like this was not like, this was not like commercial venture where you come up with a business plan and you figure out, okay, this is the market I want to serve. This is my product. This is my pricing. This is how I'm going to go up. Nothing like that.
It was still a hobby at that point?
It was totally a hobby. I never wanted to make it. Like, this is not my thing.
At that point, was coffee starting to take off? Because you're kind of in like the birthplace of a lot of this coffee movement too.
Yeah.
So
and like it wasn't. It was just still going slow. Like I would get like maybe 1 grinder a month.
Okay.
If that, the requests. And I saw those first 9 and the requests kept coming. And I was like, okay, I love this community. I love the people, and I know there is a need because I need it. So I was like, okay, I'll make another batch of 10. Right. And then that kept going for like years, literally, like a couple of years, just like 10, 10, 10, 10, just going slowly. And as you said, like the coffee started picking up and I started getting more and more requests and my batches started growing. Like suddenly I was making 10, I was making 20, or I would make then 30, then 40, then 50. And that's like completely organically, but like the first thing, like as those batches started growing, like I was like, okay, I'm going to have like the design goal at the beginning for me, like, okay, I want to design a grinder. Like, okay, why? What are my principles? So the first one was like there is this iconic machine, espresso machine called Olympia Cremina. So that's like a very old, I think the first one was made in 1960. So they are made in Switzerland. And those machines, you can still find the ones made in 60s that work.
Oh, wow.
And I was like, okay, I want that. Like, I don't want to make something disposable. That doesn't speak to me. Who cares about that? Like,
right.
Nobody wants that. So, okay, I want to make something that is simple and that's going to last. So, the simple part, my logic behind it was the fewer parts you have, the fewer things can fail.
Totally.
So that's the one thing. It's got to be simple design, it's got to be reliable. And I want to have something that is easy to repair or it doesn't need any repair, preferably. And that also means I got to use some off-the-shelf components that are, very likely to be available 50 years from now. So that went into the selection basically of the motors. And, I tried a bunch of different motors and I found these motors from Oriental Motor. So that's a Japanese company and they've been in business probably 100 years, if not longer.
Oh, wow.
And they make great DC and AC motors. And I found those and they work great for this application. They're not cheap by any means, but they're industrial motors. It's, I think the rated lifetime on the DC motor is like 40,000 hours.
Oh, wow.
So
yeah. You're going to get a lot of grinding out of that.
Yeah. And I was like, oh, that's perfect. I want that. And then that's the rest, how I built everything around that. Have to be simple. I want it to last a very long time. And if something needs to be fixed, you should be able to fix it, but generally, if you don't drop it like from high up, even if you drop it from high up, like you're going to dent things, but they're going to still work.
I was going to say, looking at the stuff behind you, it's like, I feel like that will hurt the floor more than the floor will hurt it.
Yeah. You might dent it, but it's going to work.
Yeah. So at this point, was it starting to feel more like a business? Because 50, that's, one a week that you're building? Or
yeah, no, it didn't feel like it because, I kind of love doing this. It even doesn't feel like a business today because it's no burden to me. Mm-hmm. I love doing it. So it's kind of still like a hobby. Like, I love doing it.
No, that's amazing. But at what point are you starting to think like I'm using up all of my time? I'm becoming less software engineer and more coffee grinder developer.
Well, that kind of also happened organically.
Okay.
It kind of things moved and then, I think the biggest kind of a switch was I had a surgery in 2014 that I barely survived.
Oh, wow.
It was like, touch and go for months, almost, barely. And like from that point on, I was like, it's time to change. Like, I love doing this. There is no point, I love writing software, but problem with the software is like, it doesn't last.
Mm.
The software is like, it's around for 5, 10 years and then it's gone.
Right.
15 years, it's gone. And, I was like, I can make these things and they're going to be here long after I'm gone. And somebody will be using them, and enjoying what I made. And I was like, okay, I'll do that. It seems like, now it would be a good time to switch. And I was still selling like maybe even 100 grinders a year. I don't think it's even that many.
That's still a lot, though. I mean, when you break it down, that's 2 a week that you're building and shipping.
Yeah.
That's a fair bit.
But it's not like, it's not that much, really. And, the at that time, like as this started growing and growing, the house got filled up too. Like with the supplies, and like they were everywhere.
Yeah.
The motors were stacked up to the ceiling, living room. It was crazy. But then, like I think it was maybe 2016, 2017, I had all the parts still made locally. And that was another idea behind the project. I wanted to make as much as I can locally. Reasoning being is, my thinking is you should make things where you live so you can support your local community. And if you are not making it even locally, then at least keep it in the country, so to say, And that was kind of a big idea behind all this. I didn't want to outsource it. I didn't want to send it anywhere. And everything was made, by the local shops. But, because I'm a pain in the ass, I kept pushing them on tolerances. Yeah. And of course they can do it. Like, they do it, but they don't like to do it,
right.
And it costs a lot. And, I also pushed like on some things I want 100% inspection. So that, that's even more expensive. And that always was kind of a point of friction. And I was like, okay, this is really giving me a trouble. Like, maybe I can make some of these things myself. Like, how hard could it be? It's like, it can't be that hard.
So real quick, before we go on, where did this obsession with quality come from? Because I think that I watched a great shop tour of yours. I think Brian Kwan did.
Yes.
And seeing that you're 100% inspecting almost everything now.
Yeah.
Like for someone coming at this industry, not as a manufacturer and not having a background in quality or not quality, but, quality engineering and all of that, what even told you to get things 100% inspected at that point?
Well, it's like, I think a lot of that comes from coding. Like in coding, you would usually try, when I was writing code, I wanted it to be, as good as I can do it. And then after you wrote it, you cover it with the unit tests. You cover it with the testing to ensure that it's doing what it's supposed to do. And then most importantly, once you change it, it's still doing the same thing as it did before. If you change something inside of the code, you have to know, does it still do what it did? Or if that changed, then you need to cover it with the tests or modify the tests. So, that kind of a quality control was always there, and then when I started the machine, doing this, one of the basics, like with the coffee grinding, is essentially what you are doing is you are pushing the coffee bean through a smaller and smaller opening, essentially, to simplify it. So at the end, you kind of get a powder because you are pushing the bean through very, very small opening.
Right.
So there are generally like 2 types of the coffee grinding burrs. You have like a flat burrs. So there's essentially 2 discs, 2 flat discs, and the one disc is stationary, the other one is spinning, and they have a grinding teeth on them. And the spinning burr forces the coffee through the teeth and out on the outside, from the inside out. So if you think about that, the key then to get a very fine very fine coffee grind out is that these burrs are one flat and two parallel to each other. Because if they are not flat, then or parallel, you're going to have a mixture. Like, on the one side, you're going to have a big gap. On the other side, you're going to have a very small gap. And then you're going to have a mixture of the coarse ground coffee and a very fine ground coffee. And that's kind of a suboptimal because the coarse ground and a fine ground coffee, they extract differently.
Right.
And that gives you a different taste.
Mm-hmm.
So that's what drove me like, okay, so the most important thing I can do is make sure that my stuff is flat, my stuff is parallel.
Gotcha. Okay. That makes sense. So coming at it from a flavor and a use case, you knew inherently that things had to be in tolerance and all of that. Gotcha. Okay.
And, you would be surprised, like 50 microns makes a big difference.
Oh, wow. Okay.
Like, if you order parts somewhere and you say, I need this, 50 microns at parallelness, that's pretty tight, I think, but like, it's not good enough. Like for these things, that's not good enough. And, that's kind of like why I was, so crazy about the tolerances. It has to be really, really good. And then, once I got into the coffee grinding burr design and manufacturing, that required even tighter tolerances.
Right.
Because of the way I was making them. I wasn't making them like everyone else. And that's why then I needed even tighter tolerances.
Right. So then going back to your story, I can see why these shops felt that you were a pain. If somebody came to me not knowing what you know and said, oh, I'm building a coffee grinder and I need, parallel within 50 microns or better, I would have been like, what kind of crazy person are you? It's just coffee, dude. Like, leave it alone.
Told me, like, why do we need it for a coffee grinder?
Right.
And then, I felt like, okay, maybe I could do this myself. And I watched a bunch of YouTube videos, like, how is this done? What does it do? I was like, I think I can figure this out. And I bought the Tormach lathe.
Okay.
Because my thinking was, let's get my feet wet and maybe I can do a simple turned parts, and I got the lathe in, put it in a garage. And that lathe is actually still used by Jacob from Pantechnicon.
Yeah.
Yeah, he's turning wood on it.
No way.
Oh, yeah. So, I got that lathe. I learned to turn those parts, and I was turning small stainless steel knobs. And the shafts, actually, the small stainless steel shafts. And then I learned that, and I was like, okay, this is not too bad. I need to get into the milling. And my first thinking was, I just want to be able to do the prototypes because I hate the waiting. I'm impatient. I can't wait. Like if I have an idea, I want it like today. I want to try it today.
Right.
And I was like, okay, maybe I can just do the prototyping. I don't have to do all the machining myself.
Mm-hmm.
And I was looking what kind of a CNC machine can I get, and I got the Tormach, what was it, 440.
Okay.
The weakest one.
Yeah, but 10,000 RPM versus whatever it was, 6,000 or I don't remember.
So I got that and I used it a little bit and I, kind of figured out some things. And I was like, okay, this is just not good enough. I can't like do what I want. Let's try getting something better. What can I fit in a garage? And then the Haas CNC mini mill, that would fit. That would fit through the door. That was the problem. I was like, okay, I'll get that. And, I bought the Haas CNC mini mill. Great machine. I love the machine. Like how much I didn't know, right? I got it with an auger to get the chips out. And I was like machining some parts, whatever. And then suddenly my coolant was sputtering and I couldn't get the coolant out. I was like, what's going on? I looked down, it's got enough coolant. Like And that was with the integrated coolant tank.
Uh-huh.
I was like, it's got enough coolant in it. What's going on? And I start digging, and I go into the coolant tank and it's full of chips.
Oh, no.
You just have a little bit of coolant on top.
Oh, yeah.
Oh, my God. I was like, oh, man. And then you have to like scoop it through the little window. Terrible experience. Terrible. So, but the machine was great. Like it, the tolerances were good. Everything was good. And I was like, okay, now I need a better turning machine. So what can I fit in a garage? And I got the little Doosan Lynx.
Oh, really?
Yes. So stuff that into the garage. So, and the Doosan was great. It's a really nice machine. The Lynx is, great machine.
Oh, yeah.
So I was turning things with it. But then, because of all the lead times, all the precision that I need and everything, and as I was like learning how to make things, I was like, I can take on some production too. So what's the good production machine that I can fit into the garage? It's a Brother 500.
Uh-huh.
So I put the Brother 500 in the garage, and now garage is full and you can move inside sideways only.
Right. So at this point, your garage is full, your house is full of parts.
Yep.
At what point is your wife like, all right, get it out of here?
None. She never said that.
Really?
No, she is like super tolerant, and she was helping all the time with the stuff.
Oh, amazing.
And yeah, she was never like, she's just like, I don't know where are you going to put it, but okay, but the things kind of grew out of control. It was way too much, too many orders and stuff like that. And that was a 2019. And I was like, let's try to find a shop space and get some help.
So at this point, are you 100% KafaTek and not really doing any software?
Pretty much.
Okay.
And I was like, let's get some help and see, if we can just take some burden off of me. Because it was like I was doing everything, and, my wife too. So I would assemble every single one. I would test every single one. I would machine a lot of parts. It was too much. I just couldn't do it.
How many were you selling at this point, roughly?
Oh, I don't remember. It wasn't that much. Maybe 200 a year.
Okay.
It wasn't that much. But like if you have to do everything, it's a lot.
Oh, yeah.
And then, I found a space here locally, moved in, got the house in and the brother and this, and okay, now it's good. I found a first employee to help me with the assembly. And we started doing the assembly, some production, not all of it, still a lot of it was outsourced. But I was like, okay, I have all this space, I gotta get new machine in to do like make parts.
Right.
So what can I get? I think the second one I got was the Brother 700. And we had that chick 4-wise trunnion inside of it.
Oh, okay.
Installed horizontally with the 4 axes, the support on the other end with the brake. So that was like a little horizontal machine.
That's great.
And that worked great. Like that was super productive. Great machine. And still was everything done manually. But the one thing that I kind of learned from the garage days is I was feeding the parts into the lathe, and the cycle time is like 5 to 10 minutes. And if you have to make 100, you are dying in there, just taking the parts in and out.
Oh, yeah.
I was like, nobody's going to want to do this. Like, this is like, this is too much. I got to put a robot on it. But couldn't do it in a garage, and that was always a plan. I got to put robot on my things, like just at least to automate the boring stuff. And the 700 was still manual. And that was just before the pandemic hit. I decided, okay, no, another bad thing, like at that time, was that you couldn't get easily coffee grinding burrs. So pretty much that was all the big manufacturers, they don't like to sell you those.
Right.
Because you are creating a competing product essentially.
Right.
So they don't want to do it. And at that time, I think there was a guy in Korea, in South Korea. So he started making the burrs, and I think his family background was in the cutting tools making. So they had a CNC grinders, they were making end mills and stuff like that. And I think he saw the market for a coffee grinding burrs, and he got into it, and he kind of opened up at least that part of the market. You can get good quality coffee grinding burrs.
This is SSP?
Yes, that's the SSP.
Okay.
So that's Hansung is the guy that's doing it. Great guy, really nice guy. And, I was buying all the burrs from him at that point in time, 2019. And, as I was getting deeper and deeper into this, like as it is, I think with all things, the more you keep at it, you keep, discovering things you didn't know before.
Oh, yeah.
That's how it is. Like, and, that's another thing that I always liked. Like even when I was in software, I didn't want to work in a consulting. I only wanted to work on the products. And the reason being, I liked improving things. Like, you make a first version of something, and then you iterate and you improve and you improve and you polish and you polish and you polish. And I always liked that. So that's kind of why I took all this on, because I was like, okay, I'll make a first version and I'll just keep improving. Just polish it. And then, you kind of learn things. You find out, okay, there's, things I didn't know, now I do. And I figured out, I need to make my own coffee grinding burrs. So I need to do it myself. And also reason being, there are different ideas I had about like, how can I do it differently and to get a different taste. And, I was like, I don't know if I can do it, do the coffee grinding burrs. That's like fairly complicated.
And and not only complicated, but you just mentioned that nobody shares info about it.
No.
So as someone who loves to dive into the deep end, how do you go about developing a product that has no information on it? Were you buying a bunch of burrs and then reverse engineering them, or how did you do that?
Well, it's pretty much you go in and you look and you have general idea of what's going on, right? But like there is no other information, And I had this idea, okay, maybe I can do it this way, with a 5-axis machine. And, my thinking was, 5-axis machines are expensive. And especially like the one that I would need to do that, it's kind of a Matsuura MX330 level and up.
Right.
That's probably the smallest one I could get.
Mm-hmm.
And I was like, but since that's very risky proposition, I might not be able to do it for whatever reason.
Right.
I still like to have a backup. I can use 5-axis machine for everything else. So if I buy a 5-axis machine and I can't make my own burrs, at least I can make everything else. So that kind of minimizes the risks. And, I remember I talked to these guys, Birdle Machine, to John and Mike, and I told them what I'm trying to do. I was like, what do you guys think? Can I mill this, with a 5-axis machine? They said, sure, no problem. And they, these guys, they have like over 50 years of machining experience, really great guys. They can make anything. So I was like, okay, it's possible, right? And right. I ordered the MX330 and it got delivered and installed and the pandemic hits. Oh. And now you can't get the training in, and the James was supposed to come in.
Right.
And I think that was like kind of delayed a little bit, and everything was already closed, like the lockdowns, and James managed to come in. So he came in, did a training, And then pretty much from there on was trial and error on how to make them. I would literally draw it in a Fusion. I would machine 2 pieces, put them in a grinder, make coffee, and see what happens. And I made over 100 versions.
No way.
Yes.
So this 100. Was months of development then?
It's months. And I just kept at it. Just keep going. And, every time you learn something, you figure something out. And, after those 100, about 100, there's over 100, definitely. I was like, I hit on it. I was like, this is good. This is really good. This is the way to do it.
So were you varying not only geometry, but also, material choice and heat treat? Because I know Joel St. John had asked to talk about material selection for the burrs, heat treat, coating. What was your process for making these selections? So what were you varying and how are you doing that?
The first thing I did was I was varying only the geometry. I wanted to find the right geometry to do it. So, and then I wanted material that is easily available. So pretty much was a stainless. I would take 3 or 4 stainless because these didn't need to last. It's a prototype to test the geometry, see what happens. That was a simple stainless. And I would machine that, put it in a grinder, try it out. And then once I have figured out the geometry and everything, then I moved on to the material. And essentially the material, I wanted something that I can polish because that was one of the, kind of discoveries I made on this journey, right? The surface finish of the grinding burr itself has the influence on the ground coffee.
Really?
Yes, because imagine if you drag the coffee bean on a sandpaper, what's going to happen? You're going to get fines, you're going to get powder.
Right.
But if you drag it over glass, it just goes. So that was one of the observations I made, when I saw that the surface finish has the effect on the result. And I was like, that's interesting because that's kind of hard to control. If you have the rough surface finish, you can't really control the amount of powder of the fines that you get in the output because that's going to be always constant.
Mm-hmm.
And I was like, okay, I can polish, the burrs to minimize the roughness.
Okay.
That was a big idea. And then also get the coating on them that also increases the lubricity of the surface. And then it makes them last very long.
Interesting. Okay.
So, but that also has interesting side effects, which is your precision must be super high.
Oh.
To be able to get, because here's the problem. The problem is that the fines in the ground coffee, they control your flow rate of the water through the coffee puck.
Mm-hmm.
So if you don't have enough fines, the water will just flow very fast through the coffee and you cannot build up the pressure. So usually you need, for espresso, you need 8-9 bars of the pressure. So without the fines, you can't build the pressure. And now I'm taking away the fines from the surface finish, which means I need to create them through the burr. I need to get them through the burr geometry. And the gap, essentially that is the gap between the burrs. So if I want to have a super tight, gap between the burrs, literally in microns, you need to be really precise in everything else.
Oh, wow.
So that was kind of, the side effect of that. And
you're just making more work for yourself.
Yes. And well, it's even crazier than that. So, okay, I get into the burrs, right? And okay, I need to make them flat and parallel. I was like, sure, it's a surface grinding. I'll just get the shop down the road to do it for me. So these coffee burrs, they are about 4-inch diameter, 3/8 thick. So 98 millimeters and 9 millimeters thick. And we turn them, no problem, but, they are not either flat or parallel. Like we make them really nicely, and they are parallel within 30, 40 microns out of the lathe, which is really good, but not good enough for this.
Right.
And I took them to the local shop that I found. They have a precision in the name, the grinding shop, huge, pretty big shop. And I was like, I need these ground to like 5 microns or less, flat and parallel. And he straight up, nope, we can't do it.
Oh, wow.
I was like, it's grinding shop. What do you mean you can't do it?
Right. It's in your name. What are you talking about?
Yeah, exactly. Precision grinding. It's like, no, we can't do it. I was like, okay, let me leave you 10 pieces and you do the best you can. And they did it. And it was like one of the pieces was 5 microns, the rest was over 10. And I was like, this is impossible. What do I do? Like, I got to grind it myself.
Right.
And we bought a little surface grinder, the Chevalier, because I didn't know we're going to be grinding that many. It was it's not that expensive. And I was like, we don't need something big and, stuff like that. And then we started grinding those on the Chevalier and it worked, but you couldn't grind that many at a time. It was very slow. And, the precision was so-so. We could get under 10. But,
okay.
It still wasn't, as good as I wanted it to be. And I was like, okay, we learned how to grind them a little bit. We need a production machine. So we got the Okamoto.
Okay.
And we started grinding on that. But now I think I understand why they couldn't do 10 or better.
Right.
And we started like, you can load up, I think, for maybe 18 discs on a table of the Okamoto. And, we would load them up, we start grinding, and you have a potato chip problem. You have a grinding burr, the discs, there is a slightly potato chipped, you put it on a magnetic plate, and that sucks it down. You grind the top flat, you release it, and it springs back up.
Right.
And you keep turning it. And that was a nightmare. Like, you can't do it. Like, how do you do it? It's like a thin piece of the metal. And springs back.
It only gets worse the thinner it gets.
And yes. And then I started, I was like, I got to figure this out. And I was watching, and one other thing is I said I learned everything on YouTube or reading. So even to this day, I like to watch everything machining related. Anytime somebody makes something, I want to see it. And the simple reasoning is, I'm interested in it, but also you learn stuff.
Oh, yeah.
Or at least you learn, that's possible, or that information is available and you store it somewhere. When you need it, you can just dig it out. Oh yeah, I think I saw that. I'll dig it out. And I started watching CNC grinding and just, surface grinding videos. And deep into the rabbit hole, I ran into this guy and I sent him a message on Instagram after that. And he's like, I can give you a trick how to grind these parts, the first top of the part, so it's good and it doesn't potato chip when you flip it over. So you only need to grind 2 times, side A, side B, done.
Really?
Yes. And you wouldn't believe this tip. So this is a huge tip. If you are into the surface grinding, this is a huge tip.
Okay.
So he says, take the blue shop paper, this
yeah, the shop towels.
The shop towels, and lay them down on the table put your parts on it, turn the magnet on and grind them like that. And that's it.
That's I've heard something similar. I've heard the same with like newspaper, paper towel, all that stuff. Yeah. It's something you would never think.
No. And crazily enough, it works.
Right.
Like we use it all the time.
That's amazing.
And I tried that. I was like, wow, this works. And, you know, that solved that problem.
That is. So I want to take a quick break here and talk about naming too.
Mm-hmm.
How did you get KafaTek? How did you get the Shuriken burrs? Yeah. Where did these names come from?
I always had a knack for names. You know, I always could come up with a name for something. I don't know where does it come from. Like it just comes to me. But the KafaTek specifically, the Kafa, that's in a Bosnian language, that means coffee.
Oh, okay.
And then the tech is a play on technology.
Right.
So the KafaTek. The Shuriken burrs was like, if you look at my burr, how it looks like it kind of looks like a shuriken star from the Ninja Shuriken star.
Right. Well, and that's the logo for it too on your hat.
Yes.
Right? Yeah. Uh-huh.
So that's how that name came about. The monolith as a grinder was, I made the first one and I was like, this is so freaking heavy. What the hell did I make? And it's like super heavy. I was like, this is like a monolith stone. Like you're just lifting it. And that's, you know, how the grinders ended up being named.
Okay. I love it. Very cool. So you solved your grinding problem.
Yeah.
Where do we go from here? Because there's still a bunch of machinery to add to get to where you are now. And...
So like, you know, during COVID, the demand exploded. It was just insane. And I think everybody was at home. They couldn't go to the cafe, you know, so they were like, you know, I got to make coffee at home. And, you know, then I started adding, you know, the machinery we needed to make things. And the first thing was like, I think the first thing I did was I put the UR5 robot on the Doosan link slate. And, you know, I was like, I can figure all this out, right? But I don't have time. You know, I want to do the robot programming and everything else. I can figure out the install. I've done electronics, you know, for a long time, but I don't have time. And I was looking for somebody locally to do it for me. And I found Troy.
Oh.
From Rapid Design and Lights Out. Now.
Yeah.
And he came in, you know, he installed the robot, connected it to the machine, you know, gave me some good advice, which I didn't follow. You know, like the first thing he was like, you really need a good table for a robot to sit on. Otherwise, you know, it's not going to be precise. You know, I was like, this table is good enough.
Unfortunately, machinists tend to want to make their own mistakes.
Yeah.
We all think we're a little special snowflake and that, well, no, you just don't know what I know and I'll figure it out.
Yeah.
And then we all make the same mistake and it's like, nope, you were right. I was wrong.
Yeah. That's exactly what he was like, you need a stable. And I was like, no, this is going to work. You know, it's like, it's stable enough. Like it's heavy. Look at it. You know, the table is fine. And you know, he says, you know, he told me like, you should really get pneumatic gripper, you know, don't mess with those electronic grippers. They are not precise enough. I was like, the electronic gripper is fine. Famous last words, you know, and like, and I got it to work, but it wasn't consistent. It was constant pain in the butt. It was like, but it worked to some extent, you know, but it wasn't that good. But I left it alone because, you know, there were more pressing matters. And, next thing is like, I need to make like all these bases for the grinders and other parts. And like, I didn't want to do like 3 ops, 4 ops, stuff like that. I was like, no, we are not doing that. The most I want to do is 2 ops. So that means I need a 5-axis machine. So I already had Matsura, but that was dedicated to the burr making. I was like, that's going to make coffee grinding burrs, but I need machine for the rest of the stuff. So I got the UMC 500. And immediately the idea was, I talked to Troy. I was like, what can we do to automate it? I don't want to do the material loading,
right?
Because the things change, and I change things a lot. I improve. So if I got set up for a single thing and I have to do the changeover to the new material, whatever, that's a pain in the butt. I don't want to do it. So I was like, let's do the pallet loading. And he's like, sure. And then we worked together and came out with that rounded kind of a pallet design.
Oh, so you were one of the first rotary pallet systems?
Yeah, that's the first one.
Okay, wow.
And at first I was like, I wanted the system to be, so the design goal with that for me was, I want the system that is so easy to use that I can teach my wife in 30 minutes how to run it, or anyone else. So that means that like every pallet, you can put pallet anywhere on a rack. We have, I think it's like a 28 pallets on this system, something like that. So you can put any pallet anywhere and the robot just comes in, picks it up, right? And at first I was like, okay, I need to write my own system for this. And I wrote a custom server application and then the client application for a pallet management and a job management that you can access anywhere from the shop, just from the browser. And then you can see the whole, pallet pool, and you can just tap which ones you want to run. And that's pretty much it. And you can get the status of what's running and stuff like that. And then, the first thing is like, I need to be able to identify each pallet. So I was like, this looks cool. Let's try the QR codes. So I QR code each pallet. The robot comes in with a QR reader mounted on top, reads the QR code, goes to my server, asks it, okay, what is this? The server finds out, which part is it, gives the robot back the weight, the center of the gravity, the size, and which program it should run on a CNC machine. And then robot picks it up, puts it in the machine, and runs it.
Interesting. The center of gravity stuff, I had no idea you were dealing with. I kind of just assumed that it was, picked from the same location, and it figured it out kind of as it lifted.
Well, because we have 3 different sized pallets.
Oh, interesting.
So we have a small ones, medium, and large. And so the QR codes proved not to be a great idea. Reason being coolant, oil, and then the light reflection.
Makes sense.
And then the robot couldn't read it because it was like, it needs to be able to take a photo essentially of it and read it. And I was like, what's cool? RFID codes are cool. Let's put the RFID tag on each pallet and read it like that.
Smart.
And, now every pallet's got the RFID code, and that works great. And
Did it feel good to kind of return to form and have like a full software development project in the shop?
Oh, yeah. I mean, that's great. But, here's the problem with me. My head is full of the stuff that things just go out that I don't use. So, like right now, if I have to make any modification to this code I wrote for the pallet management and stuff, it takes me like a day, to kind of pick it back up because everything went out.
Oh, yeah.
But So I got that running, and then we did exactly the same system for Matsuura with just even more pallets and the same RFID stuff, everything the same. And that system is really good. Like we often run 24/7.
Wow.
So you can let it run.
And the Matsuura is just doing burrs. So really you're just changing between type
stuff now too.
Okay.
And yeah, you just let it run. Matsuura is really nice. So 24/7, off it goes.
Awesome.
So, and now we just need to load the pallets, flip the parts, load the pallets. That's pretty much it. What else? Then I had like those 500 and 700 brother left. So 3-axis machine, one of them had a 4th-axis on. And I really liked 5-axis machines just because, and the another thing I really like is a backup for everything. I'm big into the backups.
Oh yeah.
Like I need double backup, triple backup for all my machines. So if my Matsuura goes down, I gotta be able to make it somewhere else.
Right.
And so that's why I kind of invested in all 5-axis machines, so I can move the work between them. And some of these parts, it took me years to figure out how to make them to the precision that I like. So, for example, anything that burrs, the coffee grinding burrs mount to, that's like extreme precision. That's gotta be flat and parallel to 10 microns or less. And that's very hard to do. That's especially like spinning lower burr carrier that I make, that needs to be really flat, not parallel, but square to the shaft because it's spinning. And that part gave me so much trouble to make. It took years and years. I had custom fixtures that I designed to hold it. And then because the tolerance is so tight, you can't clamp it. You can't be squeezing it. There is no way you can't do it. If you start squeezing it, no matter, how low the squeeze is, it's going to bow it out because it's thin and it's just not doable. Right. And then I was screwing it down. That's my favorite, actually, work holding method I like to screw things down. And I designed this fixture and I would screw it down and everything was torqued to like 2 Newton meters. That's like very low.
Yeah, barely.
Barely, but we could get 10 microns on those. But it was pain. Like, can you imagine, like, if you are trying to do that, everything needs to be clean as you are mounting it. You have to torque like 4 screws that are holding it. You have to torque them exactly the same, in exactly the same manner. It was painful.
Right.
It's like very hard to do. And, I kind of learned like, okay, so the best way to do this, like if you want something that is a super high precision, you got to have a good machines that have the high precision. And then what you want to do, you want to transfer that precision from the CNC machine into your part. So how I designed all my grinders is pretty much around the basic stuff like flatness, squareness, parallelism. So if I can get good machines that can mill flat, mill square,
right?
I should be able to do it. And that's kind of the idea behind it. So the next machine I think was a Brother U500.
Right, one of the 4+1.
Yes.
Ones. Yeah.
I got 4+1. No, actually, before that, I got Okuma Multus.
Oh, really?
Yes. So I got I wanted to do the conical burrs. So I was doing flat burrs, but I wasn't making conical burrs. And I also wanted to make these lower burr carriers one and done. I didn't want 3 ops. Forget it. So I wanted one and done, and I wanted perfect. So the only machine I think that could do it, that would fit the bill, was a Multus. So I got Multus B250.
Okay.
So 60 tools, great machine. And I had to create a post processor for it, for the Fusion.
Oh man.
Too. So that was a pain. And I wasn't sure, I wasn't sure 100% is going to be able to make these conical burrs, because the geometry is kind of funky. You are cutting the teeth inside of the disc. So you are not on the outside, you are on the inside. The angles are really tight. Like once you reach in, there is not much clearance, maybe 0.5 millimeter.
Oh, wow.
It's like the clearance is crazy. And I wasn't sure it's going to be able to do it. But when I talked to the, local Go-Siger guys, and I gave them like, this is what I'm trying to do, I simulated it in Fusion. I was like, can I do this with a Multus? Can it reach? And, they tried it out. They say, sure, it can. And then, I got the Multus, got the post-processor going, got that burr made. So that burr was not that hard to make, because I already had experience with the other ones. And, I kind of knew pitfalls and what to look for. So
maybe real quick, just to clarify for everyone, explain to me the whole flat burr versus conical burr, like I'm a person who doesn't know anything about coffee, because I don't.
So the flat burr, you have a simple 2 discs. The coffee comes, that are, held parallel to each other. There is a hole in the middle, in the center of those discs. The coffee comes inside, one burr spins, and that forces the coffee outside. And pretty much you are passing the coffee, as I said before, from the larger through the smaller opening. And that's pretty much it. The conical burrs is you have a cone, which is your inside burr, and then on the outside you have a matching disc kind of a thing that's got the cone on the inside that matches this outer inside cone. Those 2 cones kind of a match, and the geometry is such that coffee is again forced to go through from larger to smaller opening.
Right.
It's just in a conical shape instead of a flat shape.
So what's I feel like I've seen the rise of flat burrs. Everybody said that those are the best, and then it's kind of turned back around, and people are saying, oh no, conical burrs are the best. And so where does this argument come into? Like, what makes one better than the other?
It tastes differently.
Really?
Yes.
Okay.
And you can, like, if you get into the coffee, it takes some time until you really learn to taste. But, once you are there and you make coffee, you can taste the difference.
Is that due to size? Like, is one more consistent than the other?
It's pretty much due to the particle size distribution that comes out of them.
Okay.
It's, as the conical burr, because of how it works, it generates like 2 peaks, 2 humps in a particle size distribution. So you have a one large, and it's also the particle size distribution is stretched out. So you have a wider range of the particles, and then you have 2 peaks. One is smaller and one is a little bit larger particle size.
Interesting.
While the flat burr also has 2 peaks, but the peaks with the fines is much smaller, while the peak with the larger coffee grinding particles is like taller, and it's much tighter in the distribution. So if you say you get uniform results out of the flat burr in a particle size, more uniform than the conical burrs.
And the conical, do you get those 2 peaks because it's recutting?
Probably yes, because it's recutting. But also, like, it's not necessarily. That's why I'm not huge into the particle size distribution as far as the taste goes, because reason being the taste is subjective. Like,
right.
But to me, I design everything around the taste. I don't really care about the particle size distribution because you will not be tasting the particle size distribution. Right. You will be tasting the coffee. And that's what I designed for. I want to be, I want to create something that tastes different, better. That's subjective, right? But I want it to be a different.
Which one do you prefer? Or do you prefer them for different types of coffee?
I prefer, generally, I say conical burrs for the darker roasts, and then flat burrs for a lighter roast.
Okay.
And then there is a new, it's an upgrade of the flat burr grinder that I just made, and that's got the combination of conical and a flat burr.
Oh, really?
Yes. So it's a combo thing.
Interesting.
And that one creates like a smoother taste profile. So the coffee is very, very smooth. And as opposed to like a large flat burr where you have a clarity of the flavors, you have you can taste the different flavors in coffee. This one is more integrated and smooth. And then the conical burr is kind of a much sharper in tasting. So
interesting.
It's very, it's different. And very
cool. So, you got this Multis. At what point here do you get the Zeiss and start integrating that into your process as well?
So the Multis I got, so these lower burr carrier parts, which is a critical part, which is hard to make. So that one is also hard to kind of measure correctly. And pretty much like all of the parts that we make, it's harder to measure because how do you measure the flatness easily and repeatably for 100 parts? Like, it's not that fast. It's going to be. So I was like, we need a tool to do it. And then I looked into what else is, what can we get that can be on a shop floor. And then, that's where the Zeiss came in.
Right. Makes sense. Yeah. And I'm sure you love that Calypso keeps everything in a database that you can go back and refer to. It makes a lot of sense.
Yeah. And we got the Zeiss, and that was like huge. We use it every day. And we measure all of the parts. But like the biggest feature for us in Zeiss is pretty much the scanning of the surface. So you can take like a flat surface, you can scan it, and then you can graph the thing to see it. And like we changed a lot of how we make things based on those scans to make the parts better, because you can see the squeeze.
Right.
And even like the things that I didn't think you're going to be able to see the squeeze on is, let's say, aluminum 6061, 4 by 5 inches piece, 3 inches thick, and you face the top just a little bit, just to be, just to get, a facing cut on top. You can see the squeeze on that, which
crazy.
Is, to me, I didn't believe that's possible.
Yeah. Yeah, I wouldn't have thought either. I mean,
and you can see
an insanely thick piece. Yeah.
Yep. And here is the interesting another thing that we recently discovered. We had everything dialed in, right? And we had these low profile gripping strips that bite into the aluminum, and these were gripping on like 1/8, 3 millimeters maybe.
Right.
And we dialed the whole process in for that. And because that machine was loaded with the robot, when it drops the parts in, and the whole table is tilted, so the robot can clear the door and everything. Sometimes the part, due to the rounded edge on the extrusion, it will slip out. And we changed those strips to like, I think, to the new strips that grip on maybe 5 or 6 millimeters.
Oh, wow. Okay.
And that stopped the part slippage. But then we followed the whole process exactly the same. same pressure, same everything. We put it on Zeiss, it's not good.
Oh, interesting.
The squeeze came back, and we didn't change the pressure on the vise. So even the depth at which you grip affects the deformation on top.
Right. And
So
that's not much either. Moving it up 3 millimeters is really not much.
And we had to lower the pressure a lot.
Really?
To get back into the tolerance.
Ooh.
And we are, but we are chasing, like on Zeiss, we want like 7 microns or less on flatness on a 4 by 5 inches piece.
That's asking a lot, yeah.
Yeah. So like, and the squeeze is all responsible for that. Like literally how you hold it and how hard you grip it. That's it.
Right.
And the same is like on a lathe. You put part in a Zeiss and you scan it and you can see the trilobe of the chuck gripping on it. So that's where the Zeiss was extremely helpful. Not only we scan like all the critical parts, like we have a QR codes on the parts inside that gets scanned and that gets connected to the report for that part. So we can pull out reports for every single thing. And, that's pretty much.
That's amazing. Yeah. So you bought that around the same time as the Multus?
Yeah, I think we bought it like a couple of months after the Multus.
Okay.
And at that time, I thought I'm going to have a robot on the Multus. And no, I wouldn't dare put a robot on a Multus.
Why not?
This is probably the machine I'm scared of the most.
Okay.
Because the problem is like, especially what I noticed, you are dealing with those stupid strings and birds' nests, and they get caught into the tool changer, go under the tool. Not a good things happen. And especially on a Multus, if you crash it, the repairs will be a cost of almost a small vertical machining center.
Right. Yeah. You don't want to spend another Speedio worth on fixing the Multus. Yeah. I gotcha.
So the Multus is great machine, but it's complex.
Yeah. Yeah. I mean, chip control is always, I think, the biggest issue with automating lathes. Yeah. Especially if you're doing any kind of aluminum or anything like that. Yeah. Like if you got something hard that you can chip, it's going to be okay. But aluminum, you might think you have it dialed and then the insert wears just that little bit and all of a sudden you got strings everywhere.
Mm-hmm. And it's not only that, it's like you get different batch of material and all your dialing is out of the window.
Exactly. Yeah.
So that's also what we've been dealing with. And then after that, I replaced the Doosan with another Okuma, the LB3000.
Okay.
And then just a couple of months ago, I finally got that UR5 to work consistently.
I'm guessing a heavier table was part of it.
Heavier table? Well, no. I learned the heavier table lesson, right? So I got the table from Troy. So they have a nice table that they make super heavy. And he said, and like all other robots we have in the shop, they are, bolted to the floor. But this one, because we needed to move around the machine, I was like, this is heavy table. We don't need to bolt this one down. And he's like, you need to bolt it down. I was like, it's heavy. It was heavy enough. And then I would dial in the robot to put the parts in. And then, it would work today. It will not work tomorrow because somebody leaned on a table. And finally, we bolted the table down and it's working. It's working really good now.
Awesome.
And that's really like the robot on a lathe. That's like great thing, especially like when you are getting finished parts out. We can do like, I think 20 parts on that one. And that's like half a day of running, which is fantastic.
And is that mostly burr blanks that you're making on that?
I am not brave enough to let the burr blanks run with the robot.
Okay.
Reason is those birds' nests as the inserts start to wear and then the finish passes.
Gotcha.
And I was like, and you are dealing with, hard material are not brave enough.
Okay.
But we run the aluminum.
Gotcha. Yeah, lots of round parts in your grinders for sure.
Yeah. So, that's working great with the robot. It's really nice.
Very cool.
And then the last machine we got was a 5-axis Speedio.
Mm-hmm.
And that one we run manually for now just because we don't have space for another robot.
Because your first U500 has a robot on it,
yeah,
right?
It's got the 10E, the UR10.
Okay, and you're running the same kind of pallet pool?
No, I'm running the material loading on it.
Oh, interesting.
Yeah, I wanted to change.
So did you buy that machine knowing you were going to dedicate it to like a specific part or part family?
Yes.
Okay. Then the material loading makes a ton of sense if you're not doing any changeover.
Yeah. So essentially we just changed the jaws.
Gotcha.
And maybe a couple of tools. And yeah, that's it. And that machine is extremely productive. That's like crazy. It just runs and runs.
I bet. Yeah.
The only problem is like small chip bins from a brother. That's a huge problem. That is, I think, that's the thing that surprised me the most, that problem is not that well solved. At least in the machines that we have. I think when I talk to the Birdwells, they have the DMU, what is it? What's the name?
The small drill tap from DMG?
Yeah, the DMG, yeah.
The mill tap or something like that?
Yeah, I think it's a DMU. Is it DMU? I don't know. It's a 5-axis too.
Mm-hmm.
And that one's got, they say it has a, chip problem well solved. It's got the paper filters. It's got, but I still feel like this is crazy. Like the other day we were cleaning the coolant tank on the UMC and the bottom was full of fines, just the aluminum powder.
Oh yeah.
That's crazy.
Yeah. I'm a big fan ever since getting the Hermla of paper band filters. Like it is amazing how well they do.
Yep. Yeah. And that's like the same thing we are grinding on Okamoto. It's got the paper band filter. The coolant is fine. Like there is no fines inside. There is nothing. It's like, that's a great thing.
Yeah.
So I think that's smart. That's, in my opinion, I think the coolant tank should be practically always clean. Like, if the system is designed correctly, and I think like for a lot of these guys, these systems are afterthought.
Yeah, well, and I think it's the difference between, it seems like Japanese machines try to do integral tanks no matter what, versus a lot of these German machines, or even the higher end Japanese machines, they split it off where they're like, okay, there's the small tank for the conveyor that we can let fines get into, but then where the most of the coolant is stored, that's where the paper band is, and that's where all of like the filtering is going to be, so that by the time it gets back to the machine, we're not pumping chips at the cutting tool.
And well, that's another thing we learned. It's kind of, you got to put the filter on every single pump, on every single coolant pump. Otherwise, the chips get in, clog the lines, and then you are in trouble.
Oh yeah. Well, I would imagine, especially with a higher end item, consumer item, you are probably having to be so attentive to not only tolerance but surface finish.
That's also like huge. It's unbelievable how hard that is. Yeah. And that's not only like, I feel like we have the stuff that comes out of the machine pretty well under control, because the reason, I don't really care if it takes longer, but the part needs to look good out of the machine. And I don't want people touching it too much afterwards, because every single time you touch it, there is a risk involved. But then, what I'm trying to find solution for right now, and I think that's a huge, it's not that much of a bottleneck, but it's a pain in the ass for us, is washing and drying aluminum parts. That's like, that's really, really, so if anybody who is listening is, doing the production washing and drying of cosmetic aluminum parts, I'd love to hear from you how you do it.
Yeah. Well, I mean, we've spoke over DM that like the only solutions I've found that are very hands off are also tens of thousands of dollars.
I don't mind.
Very frustrating.
Here's the thing, I don't mind paying.
Right.
Like I want, like for any of these things, I want for my guys to have easier work life. Like it, it should be easier. If I can, I don't care what it costs, I will always invest in that to make the life for them easier. That to me makes sense.
Right.
Like, why wouldn't you do it?
So actually you brought up a point. We have talked about all the machinery you've added. How many people are you up to?
5 people total now.
That's amazing.
Yeah. It's a small shop, and I like to keep it small. I would not like to grow too big or too large. It's, I like it this way.
Right.
Because
when you're leveraging automation so that you can keep it that way.
Yeah.
Yeah, it makes a lot of sense.
So, and that's the, I think we are good size. I've got the good team, great guys, and, we get a lot of work done.
Awesome. Well, let's get to some of the questions. We got a bunch.
All right.
James's other question was, he wanted to know about how you came up with the idea for the espresso grinder, but any plans to make a coffee grinder?
Well, the last one I made, so this one, the 98 M98V, so that's pretty much for a coarse grinding.
Okay.
That was the idea, get something for a coarse grinding, but essentially any of our grinders you can use for any preparation method.
Okay. Are they all adjustable then?
They are
as
all
far as grind size?
Yep, they're all adjustable. So, usually like on these, the adjustment is like 5 microns graduations.
So that's crazy. I love it. Let's see. From Instagram, Pete asked, he'd love to hear your thoughts on the growing prevalence of Chinese quote unquote name brands in the coffee market, prosumer category. How do they break into the category? How do you see them fit into the competitive landscape, and where you see this all going?
It's pretty much like they saw the market that is available and they jumped in. That's pretty much all it is. I was among the first ones, and I think I'm still the only one manufacturing in the US.
Right.
I don't think anybody's making stuff in the US, and nobody, I think, is making everything himself, like from the burrs but I think they just saw the market and they can do it cheap, and, they just jumped in and,
Where do you see them fitting in, though? I mean, obviously, they're not going to invest the time to compete at a level like yours. So, do you see them kind of scooping up the middle?
Here's the thing: they can do it.
Right.
They can do it. It's just a question of, I think they fit in probably, middle of the market somewhere, low, medium, and they try to cover everything. And yeah.
So do you see them more as potentially a stepping stone of a potential future customer? Somebody who gets into coffee, buys a less expensive Chinese one, and then says, oh, you know what, I'd like something made in America. I'd like something that it does have 5 micron resolution on the grind size.
I think pretty much, a lot of people are like that.
Right.
A lot of people, because you just go and it's a journey, if you will, like with any hobby, and you start on a lower end and you learn things and you move up and up and up. And, I think there is a value in that. I don't think you cannot jump right to the end point, because you will not know a lot of the things. You will not be able to taste a lot of the things. Like it takes a couple of years to really learn what you like and what you don't like, and to learn, how to taste coffee and kind of for your taste to develop.
Right.
When you just start, it's like everything is just bitter.
Right.
What's coffee? It's bitter. I don't know anything else. And then, the more you drink it, the more you drink better stuff. Like all the guys that work for me, none of them were coffee guys, and they kind of developed coffee habit. I say,
I mean, how could you not working there?
So, that's pretty much it.
How would you or what would you recommend to somebody wanting to get into coffee? Like what machines do you see that are good entry points? I know the Gaggia seems like it's a very common first espresso machine. Is that what you would recommend? And what about Gaggia grinders and all that? Okay.
Gaggia is great. It's a great machine to start. There is actually the great machine that is just recently announced was a fellow, I think ES1.
We have one on order for the shop, actually.
Yeah, we too. We do.
Very excited. Yeah.
So I think that machine is, if it works well, is going to be a really fantastic entry machine.
Yeah, it seems like it. I mean, it seems like the pro version of the Gadguino, where people add like the Arduino to the Gaggia and you get pressure tracking and all that stuff. And so, yeah, when I saw it, Brad and I, we have like a Philips super automatic that, like you said, makes kind of very mediocre, bitter espresso. And we both wanted something a little nicer. So,
I think that machine is going to be great.
Yeah. And then what about grinders? Do you recommend somebody starting out, like start with hand grinders so they can really understand the grind size? Or
yes, you can do the hand grinder. I have countless hand grinders, and I gave away countless hand grinders too. But I love it, but it's like it's not something you want to do first thing in the morning.
Right.
No, you need electric. And there are a lot of good choices in like entry level.
Okay.
These days. And, there is nothing wrong with starting like that. I don't think you can jump. Like, you cannot buy experience. Let's put it that way. You cannot buy experience with the equipment.
I like that.
You have to go through the process. You have to go through the journey.
Well, and I would imagine as someone who puts as much work and effort into your grinders that you probably want a more experienced, educated customer so that they can understand and appreciate the level of craftsmanship.
And then another thing also that one of the design goals for this grinder was I wanted to ship you a grinder that when you get it, the grinder is good.
Right. With so much variability in coffee.
So that's why
check that off the list.
We test every single one and we make espresso on every single one.
Really?
And then we include a test report with every single one. Yes, we made the espresso, we dialed it in, it's good.
So what data is on a sheet like that? Because you've mentioned how taste is so subjective.
Yes.
So what are you dialing in and showing to your customer?
So pretty much like the espresso, traditional Italian espresso is defined as, say, 14 grams of coffee, making, say, 28 grams of espresso in 25 seconds.
Okay.
So that's kind of a traditional Italian definition. We are way beyond that point, right now. Like, it's not even close. But, we start with, say, 18 grams of coffee, making 40 to 50 grams of espresso within 30, 35 seconds. And then we measure extraction yield from that coffee, meaning how many solids from the coffee ended up in a cup. And that, goes into the report.
And are you looking for a low number there?
Well, you are looking, we call it the extraction yield. We are looking maybe around 20% extraction yield.
Okay.
The TDS would be, I think it's like 7-8.
Okay.
Percent TDS, total dissolved solids.
Mm-hmm. That's really cool.
Yeah.
That's amazing.
And then we know, like, if we are getting a low extraction, like, then we know something is not right.
Right. So what espresso machine are you using to benchmark all these?
We are using in the shop, we have a decent espresso. So that's what we are using.
Cool. Very cool. Let's see. Jeremy Robinson says he's an espresso connoisseur and he would love to have equipment as nice as what you're making. He's interested to hear about your process for planning out work, particularly with handling custom orders. And do you use a fancy ERP, MRP, janky Excel spreadsheet, old-fashioned paper? So how does work flow through your shop?
So the first thing we did, I used Excel spreadsheet. And like that didn't work. That was good, but I couldn't get a flow of the parts I needed out of it easily. Like what is the demand on manufacturing looking like? And then we transitioned into the ERP system online, and that worked fairly well. It took some time to kind of fit it into the shop, but they jacked up the prices to the ridiculous level that I said, nope, we ain't doing that. I'll write myself. And, I just sat down and I wrote it myself.
Oh my goodness.
So
amazing.
It's not that complicated, really. It's not that complicated. But essentially what we have right now, we are getting the online orders. Those orders flow into this ERP manufacturing system. As soon as the order flows in, that generates demand on the inventory. And then it's as simple as looking like, we have a target levels on the inventory for all the parts. And it's pretty much as simple as looking at your production table and seeing what do we need to make.
Okay. And then how about tracking things like colors and all of that through the process?
That goes all through into this system.
Okay.
It's all tracked. Like this manages the inventory too. So you know exactly like what's your inventory projection looking like? What are your minimum stock levels? The minimum stock level would trigger the production. Like as soon as you look at like part table for a grinder, the things will pop in red that need production.
Gotcha.
And then, when you combine that with the minimum levels of the inventory you want to have, that's how you dial it in pretty much.
And is that system also the one that is tying the inspection reports to the grinder?
Yeah.
Okay. So it's end to end from order to aftercare and all of that. Okay. Let's see. The Fab Lab at Utah Tech asked, what tooling or work holding solutions have made the biggest difference in your productivity and quality?
I would say the 0-point plates. We have a Lang, and we have the fifth axis on the UMC loaded with a robot is a pneumatic fifth axis. On the Matsura, it's the manual Lang, which we flip open and close manually with a lever. Mm-hmm. I think that's a fantastic system.
Yeah, but it's a great way to add automation to machines that are not automation prepped, which I think is really cool about it.
Yeah, and then also like Mighty Bites, the grippers, pit bulls.
Okay,
we use that a lot. Custom, but yeah, the 0-point is huge. Just to move things around.
Definitely. Let's see. Yo18 asked, it would be, so we talked about burr design and how it affects flavor. He knows there's also a big emphasis on repairability on your product in a positive way. So how much, we kind of spoke on why you emphasize repairability and long lasting, but how about on the flip side of that? Do you see much repairs coming back through or warranty issues because of that?
No, not that many. Here's the thing. Ideally, I don't want to have any. That's my goal. I want to have zero. I don't want to have anything coming back for a repairs. If something comes back for a repairs, we gotta figure out how to fix it so it doesn't come back again. That's always that's my goal. Nobody likes repairs. Nobody, and I don't want to be set up to do the repairs or make money from repairs or anything like that. I don't want to, I don't want it.
Do you have any stories of any things that have come back for warranty that have changed the way you've made parts?
I've seen actually, and this is still kind of ongoing discovery. I've seen a couple of times, believe it or not, bearings popping out from heat.
Really?
Yes, we use the retaining compound, the
638.
Yep, the 638 to the spec. It wasn't expired. We had everything cleaned. The stuff went to the Far East. I assume it got hot in a warehouse. Very hot.
Right.
And the stuff melted out.
Oh.
The green compound and, locked things in.
Right.
So that definitely changes then, how do we approach it? Maybe this should not be a slip fit with a retaining compound. Maybe it should be a press fit so it doesn't happen. But the press fit creates a different issue too.
Oh, yeah.
So right now, like actually what I'm going to be doing tomorrow is I'm creating a custom press fit tool.
Oh, interesting.
To press fit the bearings in, because that's kind of a key thing where everything starts. If that doesn't go straight in and clean, it affects everything else. And then we put it in on a Zeiss, we measure it, and it's not good.
Mm-hmm.
And then you have to take everything apart. So, I designed a custom tool that I'm hoping should, make us more consistent.
Wow. That's tough. That's really tough. Yeah.
Yep.
Because then you're also involving the bearing manufacturer tolerances, and it adds a whole other level of things you have to worry about.
And then we use only the SKF bearings, high quality, expensive stuff.
Yeah. Kevin Strom asked, have you ever thought about programming one of your URs to make coffee?
No.
Easy answer. Let's see. Joel also asked, do you prefer single dose or measuring the ground beans?
Definitely. Single dose, I always measure the beans, but I don't measure the output. I measure the input. I assume the output will be good.
Okay.
It's going to be, the output is usually within 0.1 to 0.2 grams of the input.
Oh, wow. Wow, that's amazing. Let's see. Spinning Slowly, he said he would love to know why you decided you needed to apply aerospace-level precision quality to every part produced. What is the best success and worst failure you've experienced during the years? Do you have any regrets in not continuing in the same field as what you pursued prior to immigrating to the U.S.? And anything you do differently to start over today? So we already talked about the precision quality and why you do that. Let's talk about best success and worst failure, and also anything you do differently.
Best success, that it was possible to do it at all. And I think the thing that I really like the most is that I can make my own burrs, my coffee grinding burrs.
I mean, that sounds very, not only unique, but very special in the space.
That's huge. The worst failure by far, crushing the multus.
Oh, I didn't realize that the repair bill came with a story. Oh no, how'd that happen? Was that during post-development?
Nope. Everything was developed, everything was working, and I think I flipped the stock on a part in a Fusion, and that flipped the Z from the back of the part to the front of the part, and I didn't notice it immediately, and I simulated, I posted it, I sent it, and that was it. Which I was very mad about. First, because obviously it's my mistake. Right? You should be paying attention. But I was also mad, the Fusion should be able to figure that out. The post should be able to figure that out. It shouldn't let me post where I'm cutting into the jaws or a chuck. That should not be possible. And I immediately extended the post to include that.
Interesting.
So my post for multus or LB3000 will not post if you are cutting into the chuck or a jaws.
So you set Z0 at the face then?
You can set it anywhere you want, because I have a machine coordinates in there, and I do the translation in the post.
Oh, interesting. Okay.
To check and it's going to arrow out and it's not going to post. If you start cutting into the chuck or into the jaws, so because pretty much all the jaws are the same, close enough, but, I set my machine, in a post, I can set what's the front of my chuck, what's the front of my jaws. And, I pick thickest of the jaws always as a test, and I can modify it if I use like smaller jaws, lower profile jaws. But now none of the machines will post if you are cutting into the jaws or chuck.
That's smart. I like that a lot.
Well, it costs a lot to fix the mold.
Right. So besides that, anything you do differently if you could start over today?
I don't know. Probably, I don't think so. Like it's hard to do. I don't think you can do anything differently, like, because you don't know what you don't know.
Right.
Like the things that you didn't know, like you can't, it's you could say maybe I should have gotten this machine sooner or later, but really you don't know. Like you need to kind of learn things. And, I like a lot of the things that I do it by feel. I can't explain it. I just, I get all the information in and then I go by a feel. Does this feel right to do or not?
Right.
And I do it. Right. I don't know how that works, but that's how I do it.
I've said it multiple times in the podcast. That is, whether to my benefit or detriment, very much how we run Protium as well. Like we look at numbers and we take all the data in and stuff, but like at the end of the day, it's just like, does this feel like the right decision for us? Yep. So I totally am right there with you.
Yep. And that's why I say, like, I don't know I don't know if I could do anything differently.
Yeah. Oh, I mean, I say the same thing because every mistake I made led me to where I am now.
Exactly.
And I'm very happy with where I am now. Yeah. Like, yes, could I nitpick every decision I've made over the past 10 years? For sure. There's a million things I wish I hadn't done, but at the end of the day, that's why I am where I am.
Yeah. Yeah. The only thing I'd say, like, it always looks like that in hindsight, but it looks like I should have moved more aggressively.
Right.
But like, maybe that would have led to the failure. Maybe the whole thing would burn out. Like,
right. Oh yeah. That's 100% survivorship bias of like, I'm thriving now. So if I pushed harder, I would have been thriving 5 years ago.
Yes.
Or like you said, I would have burned out in a ball of flames. So yeah, it's very tough to do that. Last up, and I'm guessing Sebastian is one of your employees. Aero Method asked, is Sebastian better at setting up robots or climbing, or is he just good at flexing in the mirror?
He's very good at climbing. He's a great climber, Sebastian.
Really?
Oh, okay. Yeah. He's a huge climber.
That's really cool. All right. That brings us on to shop news and new things. Anything new or exciting going on in your world?
It's pretty much, I don't think we have anything new. Like, we have no space for the new machines. We have no power for the new machines. Another thing I noticed that I have to solve is, I think I'm noticing, and I think I sent you the photo of that, the coolant drying spots of aluminum on aluminum. We just got another batch of anodized parts and half of them have those spots.
Oh, no.
And they didn't have them when we sent the parts in.
Interesting.
So either it's in the aluminum.
Do you think that maybe it was hiding in threads or something?
No, this is on top on the flat surfaces.
Interesting.
So that's another challenge. Like, we sent 100 parts, 50 of them are trash.
Right.
After anodizing.
Do you think that that's coolant, or do you think that maybe at some point in the anodizing process, they're letting them sit with, acid or remnants of the acid on the faces?
The thing is, I always like to say it's always my fault.
Right.
Whether it's my fault or not, it's always my fault.
Yeah.
Because then I can do something about it, right?
That's a great way to look at it. Yeah. And extreme ownership.
And I think, like, I look at the parts in the shop that we're sitting, like, after the machining, and I can see those same spots.
Okay.
On the raw parts. And I'm thinking it's gotta be us.
Okay.
And we scrub them, we wash them. It's like everything is hand washed and hand dried. So something there in the process, I think, is not adding up.
Gotcha. Well, I look forward to seeing how you tackle it, because I think part washing is a sticking point for a lot of us. It's never fun, and it's really tough. So I really look forward to seeing what you come up with.
We use right now a big commercial dishwasher, but it's, you still need to dry the parts.
Right.
And you still need to dry them immediately. You cannot let the water sit on them.
Right. Yeah.
So,
all right. Well, that brings us to the last questions I ask every guest every week. First up, what is one CAM, metrology, or business tip or trick that helped you this week?
Every week, definitely scan the surfaces on the Zeiss.
I love it.
We use that. That's like a lifesaver.
Yeah.
Yeah. For us, that's the key. We use it all the time. Scan, scan, scan.
And do you CMM every single part that goes into your grinders, or is it just specific ones?
We like the base of the grinder, like a side arms and stuff like that. There's no need to CMM that. But if it touches or influences the burrs itself, we CMM it.
Gotcha.
So that's the rule.
That's a lot of inspection. Are you thinking about adding a second CMM at any point?
We might, but so far it's flowing pretty well.
Okay.
It's didn't, because it's not a bottleneck.
Okay. Gotcha.
Yet.
Right. I think I know the answer for this one, but what challenge are you facing and where are you looking for help? Sounds like part washing more than anything.
And drying. It's huge. And the another thing is I think this is becoming more and more of the issue. It's the anodizing. I don't know, do you see that? And I don't know how much anodize do you do, but finding a good anodizer is extremely hard.
It's really tough. Yeah.
I don't know. And I think it might get worse. And the reason why I'm saying it might get worse is because I'm seeing the consolidation, meaning the big producers are buying out good anodizing shops so they can secure the supply.
Oh, yeah. Well, there's a lot of venture capital out there right now buying up shops and processing places like that as well.
It's cutting us out.
Yeah.
And I really don't want to do the anodize myself.
I don't blame you. I mean, it sounds like you don't have room, first of all. No. And second of all, just dealing with all the chemicals and the processes, it's a pain for sure.
Yeah, I don't want to do it.
Yeah. Let's see. Work-life balance. What does it mean to you and how do you manage it? Is it any different from 5 or 10 years ago?
No, I have no work-life balance. I just work. That's it. I only have work. I love it. When I was writing code, I was writing code 12 to 14 hours a day.
Oh, wow.
Every day. Right now I work the same way.
Right.
It's 10, 12 hours, I just like doing this. It's, I don't know what else would I do.
Right.
What do you do? If this is your hobby, and I love doing it, that's what I do.
Right.
I don't know, that I love doing it.
I can't knock you at all. I'm very much the same way. I love what I do. And it's not to say that I don't have bad days occasionally, but for the most part, I enjoy this.
Yeah.
So,
the bad days when you come to the shop and something is broken.
Right. Yeah, exactly. Let's see. What thing that doesn't really pencil out have you bought that you wouldn't be without just for the reduced aggravation, fatigue, or aversion?
It's pretty much anything that I doubled up on.
Okay.
That I like to have, as I said, I like to have backups. If I'm using a tool holder, I like to have a backup for it. If I'm using, whatever, it doesn't matter what it is. If it's a torque wrench, I like to have a backup. It's micrometer, I like to have a backup. If it's this, I like to have a backup for every single thing. The reason being, once that thing goes wrong, you really need it.
Right.
And if you don't have it, if you don't have a backup, you're going to be incredibly stressed. Or as I like to say, if you need something to ship the whole grinder, for example, and that costs $5, it's holding the whole thing because of the $5 you don't have.
Right.
So I like to have backup for everything.
What would you say is your most critical thing that you would want 4 backups for if you could justify it in your head?
Ooh, probably, well, the basic thing, air supply to the shop.
Okay.
The compressor.
Yeah.
We have two, but I think I might need to buy another one.
Yeah, it's vital.
Because the whole
really
thing will stop.
Yeah.
It's like nothing will run without the air.
Yeah, none of the robots, none of the machines, everything needs a little bit of air. So
and the breakers, the main breakers. You have backup.
Oh yeah, for sure. All right, last up, what have you been researching this week? It doesn't have to be manufacturing related. It's just interesting to see what interesting people are looking into.
For me, what was it? Part washing and drying. I'm trying to figure it out. That's like thing that's really big deal for us. How do we make it easier and more consistent?
Okay.
And I asked you too about it a couple of weeks ago. I don't think that Crest solution is not bad.
Yeah, it's just so expensive for how much you can fit into it.
That's the problem.
Yeah.
Like if I can only fit one or two of our parts, it's going to be a full-time job for somebody just to do that.
Exactly. Yeah, that was my biggest problem with it too, is I love how automated it is. Parts go in dirty, parts come out clean and dry. But it's like, man, I could fit maybe an order or two in there.
Well, it would work great for Danny Rudolph.
Oh yeah. he could fit his entire year's worth of parts in there.
Yep, easy.
Yeah. So I'm right there with you. We're also looking for something that's a little better, because right now we're hand washing in the sink with Dawn, and it works. And like we rinse with DI water, RO water, which helps a lot with water spots, but it's still not a perfect solution and it still takes time. So I'm right there with you. Well, Denis, thank you so much for coming on the podcast. I really appreciate it. Please plug, all of your stuff, where people can find you, and if they want to reach out and talk to you more.
KafaTek on Instagram, KafaTek, and KafaTek.com.
Awesome. Well, again, thank you so much for your time. I really appreciate it. And thanks to all the Patreon members who make the show possible. Let me send people like Denis a headset, microphone, and camera so you guys can see and hear us. Thank you all for listening, and I will be back next week.